See here, we have discussed the data types in last class. What is the purpose of using data types? Data types are used for representing the data type of a variable. It is going to be represents how much of data it is going to be stored in the memory and what type of data it is going to be stored in the memory. That information it is going to be represent there. There will be a default data type for default size of data type for each and every one. But the place where we are, the system where we are using maybe differs uh, the size of data type based on the system bit number. Based on the system bit number. So some operating system will be having 32 bit and some operating system will be having 64 bit. Based on that only, we'll be having this um, storage. If you want to know the exact size of that particular one, we have the size of operator. The variable exact size, if you want to know, we are going to be use the size of operator. Based on that, we are going to be coming to know that. See, we'll be having different types of data types. One is primitive data type and the other one is non-primitive data type. We have started working with primitive data types. Primitive data types. Primitive data types is also called as fundamental data types. If you see, it is either, first primitive data type we have is integer. First primitive data type we have is integer. It is either positive number or negative number without any decimal or fraction. It is either positive or negative number without having any decimal or fraction. So we have taken the example as well here. First, we have byte data type, and the range of that byte is minus 128 to 127, and default size is minus 1 byte. Default size is minus 1 byte. And there will be default value of the particular data type as well. So here we are saying that for the byte, the default value is 0. Whatever it may be the variable we have declared with the whatever it may be the variable we have declared with that byte data type will be having the default value as 0. And short, we have next short, where its range is minus 327682 to 32767. The default size here is 2 bytes and the default value is 0. Default value is 0. In a similar way, int we have minus 2 to the power of 31 to the minus 2 to the power of 31 minus 1. Till that number will be having. The default size will be the default size will be 4 bytes and default value is 0. And we have long data type. The range of long data type will be minus 2 to the power of 63 to 2 to the power of 63 minus 1. Default size is 8 bytes. Default value will be 0 or 0 L it is going to be displayed. Now, if you see a floating point data type, it is either positive or negative number with decimal or fraction. It is either positive or negative number with decimal or fraction. If you see here, float, double, we have two data types. Float default size is 4 bytes and the default value will be 0.0f. And next we have double data type where we'll be having um, default size as 8 bytes and default value is 0.0 d. 0.0 d. See here, this is a floating point data type and still we have to check uh, the default size of these data types. We'll see that and we'll see what are the character data type as well. What are the character data type? We have the character. It is an individual thing that may be See here, it is individual thing that may be alphabet, that may be alphabet, uppercase or lowercase, digits from 0 to 9, any special symbol, any special symbol, even including space, even including space, represented in single quotes, represented in single quotes. Example of that will be, this is one character, this is one character, this is one character. Even the space also will be considered as one character. Anything that is represented either in single quotes or double, oh, sorry, it is an individual item that is going to be represented in single quotes. The single item, even it is including the space, even it is including the space, even including the space, it is going to be displayed here. See, it is an individual thing that may be either alphabet, uppercase or lowercase, anything, digits from 0 to 9, any special symbol, even including the space, represented in single quotes, that is called as a character. That is called as character. These are the examples of character. And if you see the keyword, what we are using for representing the uh, character data type is char. Default size is 2 bytes. Default size. See, here there is a chance of asking question why Java, why character is having 2 bytes in Java, but in C or C++ will have 1 byte for 1 byte for char, 1 byte for char. Yeah, see here in Java, in Java for char we have for char we have 2 bytes because we are using Unicode encoding technique. Unicode encoding technique. So the full form of Unicode is universal. Universal code. We can say this is one of the reason for achieving the platform independence. We can say this is one of the reason for achieving the platform independence. Any doubt in this? For in C or C++, in C or C++, for char, we have 1 byte, because we'll use ASCII as encoding technique. American Standard, American Standard Code for Information Interchange. American Standard Code for Information Interchange as encoding technique. So it is going to be give Any doubt in this? Just a minute. Just a minute. See here, because of that only we'll be having this particular one. ASCII values, American Standard Code for Information Interchange. Now, if you see, for capital A will be having 65, for capital B will be having 66. Like that, will be having the ASCII values. In a similar way, for small letter A, it will be starting with 90, uh, 97. So like that, we'll be having even for numbers as well, even numbers as well. Okay, so this is the reason why we'll be having 2 bytes in Java. That is, we are using Unicode encoding technique. See, now next data type we have here is Boolean data type. Boolean is either true or false, either true or false. Where here it is having the storage of 1 bit. Okay, so we have next data type is void data type. It will not return anything. Anything. It will not return anything. See, void data type we are using in OSIS, it is not going to be allowed to return anything or there. Why in OSIS? See, that concept we will discuss in the functions topic clearly, or in the methods while we are discussing, we'll discuss about it clearly. Whenever, whenever we are using void as a return type, we should not return any value. Just we have to uh, write the logic of the code. If other than void, any return type like int or char, anything we are writing, at least we have to return something. If there is nothing to return, we have to return 0. That should be there. So that example I'll show you while we are discussing the classes and objects concept. So we'll see that practically. See, I'll be declaring the variables with the different types, and let me check uh, the value of it, the default value of it, if I'm not initializing any value for it. Okay, see first byte B, byte variable, the variable name I have taken as byte variable. Next short, I've taken the variable name as short variable. See, short is a keyword, byte is a keyword. All the keywords what I have represented here, it is in this particular color. Public, class, static, void, byte, short, all these are keywords. So those are represented in different colors, even package. Int, int variable, long, long variable, float, float variable, double, double variable, char, we have char variable, then we have um, boolean. I'll be taking the variable name as bool var void. So we are not going to discuss that. See, default value of byte, byte variable we are going to be access. See, directly if I'm trying to access that, it is going to be give uh, uh, error. So we cannot able to access that. I have taken these or the variables of one class into the main method. I just created the object of this particular. I've just created the object of this particular class, and I'm trying to access that for getting the default value. So how we are going to be create the object, that and all we will discuss in the coming classes while we are discussing the oops concept. While we are discussing the oops concept. See, for others also we'll check here. Default value of short, short. We are going to be access that default value of int, default value of int, default value of long, default value of float. Next we have default value for char and boolean. This is what, see, while I'm typing this, um, it is showing some suggestions, what we can call as intelligence. That is the intelligence of IDE. It is suggesting us what we can able to access with this particular object. See, these are all the things it is going to be give the suggestions to us. In that, what we can able to do, that we can able to choose. I'll execute this. Default value of byte is 0. Default value of short is 0. Default value of int is 0. Default value of long is 0. Default value of float is 0.0. Default value of double is 0.0. Default value of boolean is false. So this, I think we have forgot to mention here. The default value of boolean is false. Default value of boolean is false. If we didn't mention any value, see why we are going to be get these default values. Why we are getting these default values for the variables? Just we have declared the variable. Just we have declared the variable, and we didn't initialize the value to it. Just we have declared the variable, but we didn't initialize the value to it. If we are not initializing the value to it, it is not going to be display any value. By default, whatever it may be the value it is having, it is going to be display for that. See, for byte data type variable, I didn't declare any value, but by default, what it is having the value for that particular variable will be having for it. See, if we want to know the size of that, byte var dot size of, is going to be come as object. We'll see later then. So I think this is clear, right? How we are going to be get the default value. If we are not initializing the value to it, it is going to be give the default value for it. If we are not giving any value, or if we are not initialize any value, it is going to be give the default value. These are all the things we have. Any doubt in this? Any doubt you have in this? Please let me know if you have any doubt.
No, sir.
So these are the data types. These are the data types we have. And next we have operators concept. Non-primitive data types, arrays, classes, strings, that and all we will discuss in the coming sessions. Not now, in the coming sessions, we are going to be discuss about that. Next, we have operators in Java. What are the operators we have in Java? See, A plus B, A plus B, in this, A, B are operands, A, B are operands, plus is operator. The combination of that together, if it is performing some task, that is called as operation. A plus B, A plus B. So plus is the operator. A, B or the operand. It is going to be perform some task, that is operation. Okay. Now see here, we have three types of operators. We have three types of operators. One is unary operator. The second one is binary operator. Binary operators. Unary operators, binary operators, ternary or conditional operator. So the operators has been classified into three types. First, if you are coming to these unary operators, why they have classified these operators into three types is based on the number of operators and number of operands we have in each one. The operators has been classified into three types. Here, operators will be one, operands will be one. Operators are one, operands are one. See here, we have the unary operators. This is a unary plus. This is a unary minus. Increment, sorry, decrement. See, increment operator, see, first we'll go with unary plus. Generally, to represent a number as a positive number, we are going to be give the plus sign as a prefix to a number. Then by default, it is going to be considered as a positive number if you are not mention any sign as a prefix to a number. In general mathematics, if you are using plus sign, if you are using plus sign as a prefix to a number, it is going to be considered as a positive number. If you are not giving any sign as a prefix to a number, even it is going to be considered as a positive number generally. So here also the same thing. If we want to represent a number as positive number, we have to mention the plus as a sign. The plus as a sign. See, example plus a. To represent a negative number, definitely we have to use the minus as a prefix to a number. So that is what we have here. Unary minus. Unary minus. So increment, adding a value 1 to the existing, adding 1 to the existing value. Adding 1 to existing value. Next we have decrement innocence, subtracting 1 to 1 from existing value. Existing value. See, now here again increment operators is of two types. Post increment, pre increment. So first pre increment, the operator will comes before the operand. The operator will comes before the operand. Next we have post increment. Post increment. It means the operator will comes after the operand. Pre decrement. Here also the operator will comes before the operand. Post decrement. The operator will comes after the operand. See, altogether increment and decrement we have four types: pre-increment, post-increment, pre-decrement, post-decrement. These are the different types of increment and as well as decrement. See, pre-increment in a sense, the value will get first incremented, then it is going to be printed. The value will be incremented in the current instruction itself. Instruction itself. If it is a post increment, if it is a post increment, the value will be incremented in the instruction and update to it after completion of the instruction. The same thing will be happen here for pre-decrement, but it is going to be subtract. Sorry. If it is a post increment, even it is going to be happen the same thing. Subtracted. See, example I'll tell you. Now a value we have as 5. Pre-increment of a in a sense, here itself, here it here itself will be having the value as 5. Sorry, here itself will be having the value as 6. The incremented value. In the next instruction, if we are printing the value, also here it will be 6 only. See, pre-increment in a sense, the instruction where we have written there itself, it is going to be get incremented. The instruction where we have written there itself, it is going to be get incremented. If it is a post increment, it is not like that. A value is 5. A value is 5. Post increment. Here, the A value is 5 only. After completion of this instruction, when it is moving to the next instruction, the value will be get updated. In the current instruction, if it is a post increment, the value will be same as we have. When it is moving to the next instruction, after completion of this instruction, then the value is going to be get updated here. The value is going to be get updated here. So then it will becomes as 6. In the next instruction, post this later. Like that, you remember any one thing. Like that, you remember any one thing. Automatically, you can able to uh, remember the concept of others. Pre-increment. In the current instruction itself, it is going to be increment the value. It is going to be updated in the same variable. If it is a pre-decrement, if it is a pre-decrement, it is going to be works same to the pre-increment, but instead of adding a value, it is going to be subtract the value. Let me consider a value is 5. Pre-decrement of a, here itself, it is going to be display the updated value. In the next line also, it is going to be display the updated value only. If it is a post decrement, sorry, if it is a post decrement, a value is 5, let me consider. Here, the value of a will be 5 only. When it is moving to the next instruction, the value will be updated. The value will be updated. Like that, this is going to be work. Any doubt in this pre-increment, post-increment, pre-decrement, post-decrement?
No, sir.
So we'll see that practically. So I'll be removing this comment. I'll be writing here demonstration of increment and decrement operators. We'll see. Let's suppose a value is 10 we have declared and have initialized the value in the single statement. So now here a value if I'm displaying a value here will be getting the result as 5. Here we are getting the result as 5. Now a value of pre-increment, a value of pre-increment, a value of pre-increment. Here itself the value is going to be get updated. We are going to be get 6. A value of post increment, sorry, we have taken initially 10, right? So here it is going to give 10. Here it is going to give 11. A value of post increment, a value of post increment will be getting here, as 11 only. 11 only. See, after post increment, the value will be becomes as 12. A value after post increment. A value after post increment will be displaying here. It will be giving here as 12. It will be giving here as 12. In a similar way, see, first I'm going to be check for pre-decrement. A value of pre-decrement, pre-decrement. Here the value will becomes as 11 again. After post decrement, so the value of a value of post decrement. So in this instruction, it will be as it is. In this instruction, it will be as it is. After completion of this instruction, when it is going to the next instruction, the value will be updated. A value after post decrement, if you are giving here, it is going to give as 10. It is going to give as 10. See, as what we have expected, we are going to get the values in the output. See, for this, see, initially a value is 10. So what we have taken here, a value is 10 initially. Here we are getting the a value as 10. See, a value of pre-increment we got as 11. So 11 here. A value of post increment is 11. A value of post increment is also 11. A value after post increment is 12. A value after post increment is 12. And here, if you see, um, a value of pre-decrement, here itself it is going to give as 11. Here it is giving 11. A value of post decrement will be here 11 we have, 11 we got. And here a value after post increment is 10. So finally we got even that. Example, output of this. So this is a example of increment and decrement operators. Any doubt you have?
No, sir.
Remaining about binary operators we will discuss in the coming session. Okay.
Okay, sir.